All right, so how'd you do with the simplifying radical expressions, the product rule homework? I'm going to provide this explanation video to help you check your work and to further understand how to do these problems. Now, the square root of 20, you want to split that up into two numbers. They have to multiply to be 20, but one of them needs to be a perfect square. 4 is a perfect square, so that'd be the perfect number to be able to take out. When you take that 4 out, it reduces down to be a 2 because that's the square root of 4, and it leaves behind the 5. So we get 2 root 5. How about the cube root of 54? Now this time we want to find two numbers that multiply to be 54, but one of them has to be a perfect cube. Remember your perfect cube list? 1, 8, 27. Now these numbers on this list are perfect cubes because they come from multiplying a number together 3 times. And 27 multiplies to be 54. That is 27 times 2. So now we're able to take out this 27. Now when you take out 27, you do the root of it. And that, of course, would turn out to be the number 3. It leaves behind root 2, cube root of 2, so we get 3, the cube root of 2. How about the cube root of 24? Now, a mistake for this problem would be to think about maybe using the number 4. It's tempting to use the number 4, but the problem is that the number 4 is not a perfect cube. We want to be using numbers that are on the cube list. And again, that cube list, well, it contains the number 8. Because 8 times 3, and of course 8 is your perfect cube, is able to come out as a 2. It leaves behind that cube root of 3. So we have 2, the cube root of 3. Now here I helped you think about a perfect number that's inside of 125. That perfect number, a perfect number that's inside of... All right, so here we're trying to find a perfect number inside of 250. Now I gave that number to you, it's 125, but do you realize that you can do the cube root of 125? That's going to go all the way back down to 5, and it leaves behind the 2. Nothing changes there, so the cube root of 125 is 5, but when we simplify this answer, we get 5, the cube root of 2. All right, now when we're doing variables, we kind of want to think a little differently. That is, we want to think really about just dividing these numbers. It turns out that you can divide 18 by 3, so this whole x to the 18th is able to come out. It gets divided, and it turns into x to the 6. I can't divide these numbers, not as is, but what I can do is I can split up 20. In other words, to find the highest number inside of 20 that divides by that 3. And the highest number inside of 20 would be an 18. Now, there's still going to be x squared left over, but here again, I'm able to take out this x to 18. That is, I'm able to divide it. It leaves me with x to the 6th. But the x squared stays behind. So it's x to the 6th, the cube root of x squared. Okay, we can have multiple variables. We just want to be splitting up each one individually. Find the highest number inside of 17 that divides by 5. You should be thinking about a 15, that is a to the 15. Now I would still have an a squared. This b to the 15th, there's no reason to split that up because all of that divides evenly with this 5. So when I take out my perfect 15, that's going to divide. It's going to end up being 3. When I take out all of this 15, it's also going to end up being 3. That is b to the 3. And the only thing that's left behind is this a squared. So we're left with a cubed, b cubed. The fifth root of a squared. Now this problem is assumed to be a square root when you don't see the root written. Since that's the most common root, we'll think of that as an a squared, as a square root. We'll want to think about splitting up x to the 3rd, into an x squared and an x, and we'll want to think about splitting up y to the fifth into a y to the fourth and a y. Now, both of these guys are the ones that are going to come out. Make sure when they come out that they divide. So x squared divides just to be x, or x to the 1. Y to the fourth divides to be y squared. And it leaves behind both of these single x and y. So we have x, y squared, root xy. Xy squared root xy. Now, when you have two radicals, you're able to reverse the product rule. You're able to multiply these together. When you multiply them together, you end up getting 32. And when you add those exponents, you get x to the 8. Now, this again is a square root, so we're going to want to try to split up 32. Of course, we're going to want to split it up into two numbers, one of them being a perfect number. Go as high as 16. 16 is a perfect number that's inside of 32. Of course, we also have a 2 that multiplies to be 32. Now, when you rewrite this, you can think of it as 16 times 2 times x to the 8. Now, the 16 is the one that's going to come out. You take its square root when it comes out, so you get 4. Now, this x to the 8, we didn't do anything with that because that whole thing divides evenly. And, of course, you divide when you have a variable, so that's going to leave us with an exponent of 4. The only thing that's left behind is the 2. So we have 4x to the fourth root 2. For this last problem, you should notice that there are different roots. That is the third root and the fifth root. So please don't get underneath here and multiply together. The roots have to be the same. But you can do this math. You can do the third root because there would be a 6 that's inside of this 7. That is an x to the 6. There's also an x left over. But it's this x to the 6 that I'm going to be able to take out. It's going to divide when I take it out, so that leaves me with x squared. There's still going to be an x left behind, so let's make sure that that stays underneath. How about this x to the 15th over here? The whole thing is able to come out. The whole thing is able to divide, so that leaves us with an x to the third. Now, both of these x's are on the outside, so they're able to multiply together. They're able to come together. And, of course, you add the exponents in this case, so we get x to the fifth, but we still have this root x left over. Now, if you would like some additional practice problems, I encourage you to take a look at the Nearpod. It is optional, but you'll be glad you did it, as we're going to add another idea to this product rule in the next day.